Good morning and good afternoon, class. Today I will be teaching from this video. If at any point during the video you need to pause it to write something down, please ask the sub to do so. If you need to rewind it so you hear an explanation again, or if you need to discuss something, please do so. Um, so what I would like for you to do is go ahead and take out yesterday's notes right here. They look like this, the transformation notes. And also at this time, the sub will hand you today's notes, which look like this, and you are going to place them side by side on your desk. At the top of the new notes for today, I want you to go ahead and write the equation that we used yesterday to move the parabola from left to right and up and down, and to flip it upside down. Go ahead and write this equation at the top of your paper. All right, so let us kind of review yesterday's notes. When we have a positive, here, let me get my pen. When we have a positive a value, or a negative a value, something's going to happen to our parabola. Now find what happens on your notes. A positive a value means the parabola opens up, and a negative a value here in front of the parentheses or in front of your x means the parabola opens down. Now if we look at the d value, okay, if the d value is positive or if the d value is negative, find that on your notes and point to what happens. The positive d value means the graph is going to make a vertical shift upwards from the origin. It's going to move up. And if that value, the d value, is negative, it's going to shift down from the origin. Now let's look at the c value, which we saw right here. Okay, and this value was a little tricky because of what happens when we plug in the number. So let's talk about that. If I plug in a positive number into c right here, I'll get x minus, that's the part of our formula. And if I plug in, say, a positive 3, it would look like this. But even though I plugged in a positive 3, the negative was a part of the formula. So the positive 3 actually becomes a negative 3. And that makes the graph shift to the right. So if you have a negative number in your parentheses, the graph shifts to the right. And if we had a negative c value that we plugged in parentheses, we'd have x minus, which is our formula, and then say I plugged in a negative 5. Okay? Well, what happens is I have the negative from the formula combined with the negative from my negative 5, and two negatives next to each other like this cancel each other to make a positive. And so in this situation, when you have a positive inside your parentheses, the graph is going to shift to the left. Okay, now go ahead and put those notes next to today's notes, and let's look at the two graphs on top. There's graph Z and graph Q. Let's look at graph Z and go ahead and talk about the things that we looked at yesterday. And then after that, we're going to add the new stuff for today. So let's look at our parabola. Is it opening up or is it opening down? Okay, Well, in this case, it's opening down, which means our A value is going to be negative. Now let's look at, did it shift up or did it shift down? If we're shifting the graph up or down, are we looking at the C or the D value? If you said the D value, it's going to be correct. So let's go ahead and start from the origin with the parent function and see how far up or down it moved. Okay, so if the blue parabola is the parent function, I moved up by 1, 2, 3, 4, 5. So my D value is going to be a positive 5. Now let's look at if the graph shifted left or right. So we know we're looking now at the C value that we plug in to the formula right there. Okay, so we moved up by 5. Now did we move left or right? And by how much? We moved right by 1, 2, 3. Okay, so then my C value would be a positive, I'm sorry, let me erase. Okay. It would be a positive 3 that we plug in for this C value. Okay. So far what our formula would look like is y equals, in front I would have a negative, okay, parentheses x minus the C value that I plug in is a positive 3, put my squared, and then my D value at the end would be a plus 5. Okay, so that is what we have so far from what we learned yesterday. And it looks like I forgot to rotate my parabola or flip it upside down. So let me do that. Or flip my parent function, I mean. Yeah. That. Okay. There we go. Okay. So now let's look at graph letter Q at the top of today's notes. All right, so let me grab my parent function because we're always going to compare it back to the parent function. Okay. Well, okay. So looking at our A value, is my parabola opening up or is it opening down? Okay. Well, it's opening up, so I have a positive number in front for my A value. I don't know what that number is yet, but I know it's going to be positive. Okay. Let's look at our D value. So did it shift up at all or did it shift down at all? And if we compare it back to our parent function in blue, which we always have to do, we went down by 1, 2, 3, 4, 5. So I know that my D value is going to be a negative 5. Now let's look at our C value. Did it shift to the left or did it shift to the right? If you said to the left, you are correct. And by how much? 1, 2, 3. So my C value is going to be a negative 3. So if I was going to say write my equation out or ask you to match the correct equation, so far we would have y equals, I have a positive value in the front, x minus, okay, because x, the minus is part of our formula, and we plug in the c value of -3. We have the squared right here, and our d value at the end is -5. Now, some of you may have already noticed a negative and a negative make a positive. Okay, so that was a review from yesterday. If you need to pause it or rewind it, please go ahead and do so. Right now, we're going to go ahead and move on to the new information for today. So yesterday, we moved the parabola left and right, up and down, and flipped it upside down. Today, what we're going to be doing is stretching the parabola to make it taller and skinnier, or we are going to be compressing the parabola or pressing it down to make it wider and fatter. Okay? So, for example, let's just look at, it's not on your paper, but just to give you guys a visual of what's happening. If I stretch something, I'm looking right here at this smiley face that's being stretched, okay? If the blue parabola is my parent function, and I take it and I stretch it, it's going to give me the green parabola. I stretched it to make it taller and skinnier. And another way of saying that, or a fancy way of saying that in math, is a vertical expansion. It expanded vertically. It stretched vertically. It got taller and thinner. And if I were to take this parabola and compress it, if I'm looking at this smiley face here, it's being pushed down. Okay, it's going to get wider. So my parent function is the blue, and if I compress it, it'll become the red. Okay, it becomes fatter or wider. Okay, and so in math, a fancy way of saying that is vertical compression, to press down or make wider, as what's happening in the smiley face over here in this picture. So that's what we're going to do today. Look at how this situation, making it, stretching it or compressing it, how it affects our A value in the front right here. And so that's what this slide says. Now we will discuss how vertically stretching, which is right here in green, vertically stretching, and compressing, which is right here in red, the parent function affects our A value in front of our equation. All right. So now please look at today's notes. At the top, it has a summary and it has some information. So I have a highlighter here, but what you can do is underline this information. Okay. Right here it says, right here, it says, if our A value is between 0 and 1, and what I want you to underline is the simple way to say that, if A is a fraction less than 1. So for example, 1/3, 1/2, 1/4, 1/6, 1/10, things like that. If A is a fraction, then the graph will vertically compress. So if A is a fraction, we're going to press the graph down to make it wider. Now looking here at the last sentence, it says if A is greater than 1, the graph will vertically expand. And what we can do right here is write out that means A is greater than 1. So 4, 5, 6, 7, 8, 9, 10, 100, 1,000. If the A value in front is greater than 1, the graph is going to vertically expand, which looks like this, stretching it and making it taller. Okay, and let me highlight that right here. Vertically expand. If you need to pause, rewind, anything like that, go ahead and do so. All right, so give me 1 second while I copy some pages here. Okay. So now, going back to the 2 graphs at the top of our paper, what we're going to do is use the new information to figure out what the number in front, our A value, might be. Is it going to be a fraction because it was compressed or because it became wider? Or is it going to be a number greater than 1 because it was vertically expanded or stretched? Okay, so looking back at graph letter Z, we already talked about everything we learned yesterday. So now let's look at today's new information. Okay. There are some boxes down below. Let's go ahead and fill in what we already have. We know the A value in front is going to be negative. We know that our C value inside of the parentheses is a -3. And we know that our D value at the end is a +5. Okay, so let's go ahead and look at what this number in front might be. Well, first of all, let me again, like we always do, compare the parent function in blue to my new parabola in black. So think to yourself, from the blue to the black, did it get wider or fatter, or did it get skinnier, taller, and thinner? Well, if you said it got skinnier or taller and thinner, that is correct. And if we look back at the top of our notes, to stretch and make taller or skinnier means to, looking in red, it means to vertically compress. Oh, I'm sorry. I'm looking at the wrong thing. Let me erase that. Ignore what I just said. Okay. Okay, so again, looking at graph Z, we saw that it got taller and thinner, or skinnier. So looking back at our notes at the top of our paper, we know that that's a vertical expansion. It expanded vertically because it got taller and skinnier. And we know that that means that our A value is going to be greater than 1. Right? So our A value in front should be greater than 1. Okay? Now here we have several options that are greater than 1. We have a +5, and we have a +3, and we have a +2. Now, how do we know which one it's going to be? Okay, well, let me start with the +2. I'm going to plug in a +2 right here. And the next thing I'm going to do is use my calculator. So everyone, please find a calculator. I did replace the dead batteries, so they should all be working now. If for some reason there's not enough and some don't work, go ahead and share. We're going to type this equation into our calculator. So Where's my calculator? Okay. All right, go to our right here, y equals. All right, we have our equation is negative 2 parentheses x minus 3 parentheses squared, and the squared button is right here. So you have to type in your x, I'm sorry. So we have our close parentheses, and now we need to square it, just like that. And then at the end, we have plus 5. Okay? So what I'm going to do is look at my graph. Okay. All right, we can say that works, but we can't be for sure. So how can we use a calculator to be sure? What I'm going to do is look at some of the points on my graph and match it to the points on the calculator. Okay, so let's look at the vertex, our maximum. So that point is 1, 2, 3, comma 1, 2, 3, 4, 5. Okay, so 3, 5 should be in our table. And I see that point right there. Okay, cool. Now let's check some of the other points. Let's see, this point right here, let me move the parent function out of the way. Erase this. This point here is 1, 1, 2. So 2, comma 1, 2, 3. 2, comma 3 should be on my table. So let's check. Is 2, comma 3? Yes, it is. Let's check is its pair, its symmetrical pair, 4, comma 3 is on our parabola. So its symmetrical pair would be here. 1, 2, 3, 4, 1, 2, 3. Okay, cool. So it kind of looks like this is indeed the correct equation. Okay. We had a vertical expansion, or it was made skinnier as compared to the parent function. So we knew that our a value had to be greater than 1. And let me go ahead and write that there to summarize. With the new information, okay, it got skinnier, or what we call taller, or in fancy math language, it was a vertical expansion. Okay, so we know that our a value had to be greater than 1. Okay, and this information, we found that at the top of our notes right here. Under vertical expansion, a is greater than 1. If you need to pause it or rewind it, or discuss things or ask questions to each other, please go ahead and do so. Now let's look at graph Q. Okay, let's go ahead and fill in what we had here. Our d value at the end is -5 because it moved down 5. And in parentheses we had plus 3 because it moved to the left 3. And we know in front we're going to have a positive a value. Okay? So let's summarize the new information to see if we can figure out whether a is going to be a number greater than 1 or whether it's going to be a fraction. So if I compare the new parabola that I got when I moved it around to my blue parent function, okay, it looks like the parabola actually got wider. Okay, it got wider. Okay, and if we look back at our notes, okay, to get wider means to press it down, like if you took a hula hoop and pressed it down, it would get wider. Okay, so the fancy word for that is a vertical compression. So wider, and another way to say that is vertical compression. Okay, and if we look back at the top under vertical compression, that tells us that our A value is going to be a fraction. Okay, so this information tells us that A will be a fraction. Okay, so if I look at all my choices, the only fractions are -1/2 and +1/2. But I know that my parabola opens upwards, so I have a positive A value, so I know that my fraction is going to be +1/2. All right, now let's go on to the next section and get a little bit of practice with this. Right? Right here where it says quadratic parent function, let's go ahead and write what it is. Y equals, say it before I do. Say it before I do. Why are you hesitating? You in the back? Yeah, you were right. Y equals x squared. I know, I heard you too. I know. I heard you. Okay. So here we have the quadratic parent function on the graph, and it also gives us the table if we were to put it in our calculator right here. Okay. Look at these three functions. Each graph is either fatter, meaning vertical compression, or skinnier, meaning vertical expansion, than the parent function graph. Okay? And it's asking us to kind of remember what we just talked about. The parabola, if the parabola has been stretched or expanded vertically, what should the A value be? Write it down. If my parabola has been expanded or stretched and made skinnier, my A value should be greater than 1. So A should be greater than 1. And where did we get that information from? At the top of our notes right here. If A is greater than 1, then the graph will vertically expand. Okay, and for this one, the parabola has been shrunk or compressed and made wider, then the A value is, go ahead and write it down. The A value is a fraction, okay? So it is a fraction. And the fancy way of writing that is saying our A value will be between 0 and 1. So A is a fraction. Now let's use the information that we just kind of summarized to look at number 1 and figure out is it an expansion or a compression. So number 1, my A value is a +2. A +2 is greater than 1, so I know it has been vertically expanded or stretched. Okay, so for this graph, vertically expanded or stretched. Another way to say that is stretched. You can also say thinner or taller. Okay? Oh, that's probably too small. All right. So Now let's talk about graph number 2. No, okay, whatever. Let's look at our A value. It is a negative 1/4, okay? Well, the negative just tells me that it's going to be opening down. And the 1/4 tells me that it is a fraction, which means it's going to be vertically compressed. Okay, so let us kind of type that up. We had a fraction, so it's going to get wider, or in a fancier way of saying it, vertically compressed. Okay. Now let's look at number 3. Okay, we have a value, which it happens to be positive, so we know it's opening up as the picture tells us, but also it is a fraction. So we know it's going to also be vertically compressed, which is the same thing we wrote for number 2. Okay. So if you need to, pause the video so that you can write those things down. Go ahead and turn your paper to the back. Okay, turn to the back. Okay, go ahead and rewrite our formula at the top of the paper. Y equals A parentheses x minus c parentheses squared plus d. Right? So just we need to talk about a little extra note here. Sometimes your A value is going to hide itself and look a little different. So let's talk about that so when we see it hiding, we can find it. Okay? So at the top of your paper at the back, it has this sentence right here. Go ahead and cross that out. The value of B can be rewritten to act like A. Cross that out, and I want you to write this. Okay, write what I type. Oops. Okay. Okay. Sometimes A, our A value in our equation, okay, sometimes A will hide. What the heck? Okay. Sometimes A will hide. When it does, we need to rewrite it. Okay, so again, cross this part out and rewrite this right here. If you need to pause it to do so, please go ahead and ask the sub to pause it for you. We should be done writing this by now. So again, we should be seeing this A value in front of the parentheses. But if you look here, it's actually inside. Okay, we have the parentheses here, and then we have a number inside the parentheses, and then the squared outside of the parentheses. Well, I usually see my A value here in front. So because it's not there, we need to rewrite it. This is a situation where A will hide itself. So let me show you how we rewrite it. Okay. So another way of saying 3x squared is 3x, and make sure you write it down. Eraser, sorry. Is 3x times 3x. Whenever something is squared, all it means is that we are multiplying it with itself. Okay? We are multiplying it with itself. So 3x times itself. Okay? Now we can break this down further into 3 times x. We have 3 times x right here times 3 times x. Okay? And furthermore, let's put the numbers themselves in front and the letters in the back. We have 3 times 3 times, put our letters in the back, put our variables in the back, times x. Okay? Now let's look what happens right here. What is 3 times 3? Well, it's 9. And what is x times x? Some of you may know, some of you may not. But x times x is actually what gives us x squared. Okay? So this equation can actually be rewritten as y equals 9x squared. And now I have my a value. I took it out of hiding. Okay? That may not have made sense to you. Let's go ahead and do another one. 1/2 x in parentheses squared. Let me change colors for you. Okay, so again, I know I need my a value out front, but it's not, so I need to go ahead and take it out of hiding. Okay, and again, whenever we square something, we just multiply it by itself. So this is actually 1/2 x times itself, 1/2 x. Okay, and then we can break it down even further into 1/2 times x times, so 1/2 times x times 1/2 times x. Okay? And if we keep going, put your numbers in front and variables in the back. We have 1/2 times 1/2 times x times x. Okay? And now all we need to do is just multiply what is 1/2 times 1/2. Well, let's check this in our calculator. Okay? So let me go to the home screen. I just need to multiply two numbers together. Fractions go in parentheses. So parentheses. 1/2, 1 divided by 2, times 1/2, parentheses 1 divided by 2. Enter, and that gives me 0.25, but I want it as a fraction. So then I press math, enter, enter. 1/4. Okay? So I get 1/4 in front, and x times x gives me x squared. Okay? So I can actually rewrite this equation as y equals 1/4 x squared. Okay? And now I have my a value in front, okay, which is a fraction. So answer this question. Does that mean that my parabola is going to get wider, meaning vertically compressed, or is it going to get taller and thinner, meaning vertically expand? Look back at the front top of your notes. If you said compress, you are correct. And again, that is also meaning wider. All right, let's do one more of these. Let's look at the last one. All right. I have my value inside parentheses. It's hiding. I want it in front of parentheses. So let me take it out of hiding. Let's go ahead and rewrite this. Now this one's a little different because we have a negative out in front. So keep your negative in front. Okay. 1/3 x squared can be rewritten as 1/3 x times itself. 1/3 x. And guys, if you want to pause this to go ahead and work it on your own, and then you can play it to see if you did it right, that would be a great idea. Let's see. All right. So then we can break this down even further. Don't forget your negative out in front. Okay. And that's 1/3 times x times 1/3 times x. Okay. Now let's put all the numbers in the front and the variables in the back. You have a negative out front. You have 1/3, which is this one here, times 1/3 times x times x. Okay. Now, our last step, keep your negative out in front. Okay. And we need to multiply 1/3 times 1/3. Let's go back to our calculator. Okay. Fractions go in parentheses. 1 divided by 3 times 1 divided by 3, or 1/3 times 1/3. That gives me this decimal, but I want it as a fraction. So then I press math, enter, enter. And it gives me 1/9. Okay. So then we get negative 1/3 times 1/3 is 1/9. X times x gives us x squared. So this equation can be rewritten as y equals negative 1/9. Oops, that's not a 9, that's a G. Let me erase it. Eraser. This is not working out for me. Okay. There we go. Negative 1/9 x squared. Okay. So now I have my a value out in front right there. And I can say, okay, it's negative, so I know it opens downward. And I know it's a fraction, so I know that it is a vertical compression. Okay, so it gets wider. All right. It should be almost time to go at this point. So if you have enough time, please look at the last section and look at numbers number 2, number 3, and I want you to describe what's happening with those parabolas. Okay? So take a second to think about it. Pause the video, and then you can press play. So for number 2, I have my a value in front. So I have my a value, which is 4, okay, which is a positive number. So I know that my parabola opens upwards. And also what we learned today, a is greater than 1, right? Because 4 is greater than 1. So our a value is greater than 1, which means it is going to be a compression or expansion. It is going to be a vertical expansion. Okay, which means that it gets taller and thinner. right? And we're going to neglect number 3. Your teacher would like you to complete the rest of the back part for homework. Bring it back on Monday. Thank you all for being focused today and not causing any issues for the sub and doing your work. We will do more practice next week. We'll get you prepared for your assessments and your test, which is coming up in 2 weeks. If you need help, come into tutoring. There is a tutoring schedule taped to the window of every algebra teacher's room. Okay? Have a good weekend, guys. Goodbye.